Image formation relies on the principles of optics to capture and reproduce visual information. A camera lens serves as the primary tool for channeling incoming light rays. The lens focuses these light rays, bending them to converge at a specific point. This convergence creates a focused image of the scene being captured. The focused image is then projected onto a sensor within the camera. The sensor records the light, converting it into an electronic signal that forms the final image. Both old box cameras and modern smartphone cameras operate on the fundamental principle of light capture. The core function involves gathering light through an optical system. This light is then directed onto a light-sensitive medium. In older cameras, this medium was typically film, while modern cameras use digital sensors. Regardless of the technology, the underlying principle of capturing light to form an image remains consistent. Photography has had a profound cultural impact as a versatile and accessible medium. It serves as a powerful tool for preserving personal and collective memories. Photography is widely used for documenting significant events, both large and small. It has become an essential part of wedding celebrations, capturing key moments for posterity. Wildlife photography plays a crucial role in documenting biodiversity and conservation efforts. Street photography captures candid moments of everyday life, reflecting social trends and cultural nuances. Modern cameras come in various forms, including DSLRs, mirrorless cameras, film cameras, and smartphone cameras. Each camera type employs distinct technologies to capture images. DSLRs use mirrors and prisms to direct light to either the viewfinder or the image sensor. The fundamental purpose of all cameras is to capture light and preserve moments. A DSLR camera utilizes an internal mirror mechanism for image capture. This mechanism reflects light into an optical viewfinder, allowing direct image preview. DSLR cameras are known for their robust build quality and durability. A key feature is lens interchangeability, offering versatility in focal lengths and perspectives. Manual control features provide precise adjustments, favored by professional photographers. Mirrorless cameras represent a modern advancement in professional photography equipment. A key feature is their lighter weight compared to traditional DSLR cameras. They utilize faster processing speeds for enhanced performance. Mirrorless cameras rely on digital screens for image preview and settings. The absence of a mirror mechanism contributes to the compact design. These features position mirrorless technology as forward-looking in the field. A camera operates through the interaction of several key components. The lens is responsible for focusing incoming light onto the sensor. The shutter controls the duration of time the sensor is exposed to light. The aperture regulates the amount of light that passes through the lens. The sensor records the light to generate the final image. These components work in harmony to capture and create images. A camera lens operates by collecting incoming light rays from a scene. The lens then bends or refracts these light rays as they pass through its curved surface. This refraction causes the light rays to converge at a specific point behind the lens. The point of convergence is where a focused image of the scene is formed. A well-designed lens ensures the resulting image is sharp, clear, and accurately represents the scene. This process mimics the function of the human eye, which also uses a lens to focus light onto the retina. The shutter mechanism controls light exposure onto the camera sensor. It functions as a gate, opening and closing to regulate light entry. The duration the shutter remains open determines the exposure time. Exposure time is crucial for image brightness and clarity. Proper shutter control prevents overexposure, where the image is too bright. It also prevents underexposure, where the image is too dark. A camera's core components include the lens, shutter, and sensor. The lens focuses light onto the sensor. The shutter controls the duration of light exposure. The sensor captures the light to form an image. Each component plays a critical role in the image capturing process. Understanding these parts clarifies how a camera functions. Camera lenses function by converging incoming light rays. This convergence bends the light, directing it towards a focal point. The focal point is where the light rays meet to form a sharp image. The clarity of the lens is crucial for achieving a sharp and well-defined image. The lens's primary role is to accurately focus light onto the camera's sensor. This focusing process relies on fundamental optical principles. A camera shutter controls the duration of light exposure on the image sensor. The shutter opens and closes rapidly to regulate the amount of light. This precise mechanism ensures optimal image brightness and clarity. Shutter speed is a critical factor in determining image exposure. Faster shutter speeds reduce motion blur and decrease light exposure. Slower shutter speeds allow more light, but can introduce motion blur. The exposure triangle is fundamental to photography. It consists of three primary camera settings: shutter speed, aperture, and ISO. These settings work together to regulate the amount of light that hits the camera sensor. The interplay of these settings directly influences the brightness and overall exposure of a photograph. Adjusting each setting affects not only the exposure, but also other aspects of the image. Mastering the exposure triangle is essential for achieving desired photographic results. Shutter speed is the length of time a camera's shutter is open when taking a photograph. It is measured in seconds or fractions of a second. A fast shutter speed freezes motion, ideal for capturing sharp images of moving subjects. Conversely, a slow shutter speed allows motion blur, creating a sense of movement. Slow shutter speeds are also useful in dim environments to capture more light. When using slow shutter speeds, a tripod is recommended to prevent camera shake. Aperture refers to the opening within a camera lens that regulates light passage. Aperture size is quantified using f-stops, such as f divided by 2.8, f divided by 8, and f divided by 16. A wide aperture, small f number, yields a shallow depth of field, blurring the background. Conversely, a narrow aperture, large f number, produces a large depth of field, keeping both foreground and background sharp. Wide apertures are beneficial in low-light scenarios due to increased light exposure to the sensor. Narrow apertures necessitate longer exposure times or higher ISO settings due to reduced light. Photographic composition involves strategically arranging elements within a scene. The goal is to create visually appealing and impactful images. Effective composition guides the viewer's eye through the photograph. Ultimately, good composition enhances the story being conveyed in the image. The rule of thirds is a compositional guideline that enhances visual appeal. It involves dividing an image into 9 equal parts, with 2 horizontal and 2 vertical lines. Key subjects should be placed along these lines or at their intersections. This placement creates a more dynamic and visually interesting composition. Centering the subject often results in a less engaging image compared to using the rule of thirds. Leading lines are compositional elements used to guide the viewer's eye. These lines direct attention towards the primary subject of the photograph. Roads, rivers, and pathways can effectively serve as leading lines. Leading lines enhance depth and visual interest within the image.